Hello everyone, in this video I will discuss the hub design for this dome, and the next video in the series will detail the strut design. This is a 3V 3/8 dome, so it will require a total of 46 hubs consisting of 25 6-way, 6 5-way, and 15 4-way hubs that will be used along the base. Because of the large span, this dome is going to need a hub that can withstand a great deal of compression force. Plus, it must be able to withstand the downwards force from heavy snow loads during the winter. The first hub design had hanger bolts anchored into the end of each strut. The end of each bolt would go through a hole in a piece of Schedule 40 3.5-inch steel pipe, which was used as the hub. The strut was tightened to the hub with a washer and nut. This is the first prototype using the hanger bolt method in a PVC hub. The triangulation between each section is extremely strong. When I created a full-scale prototype, the leverage of a full-length strut and removal of the triangulated pieces caused the hanger bolts to easily pull out the end of the struts. The second hub design was similar to the hanger bolt design, except the hole was drilled through the strut and a washer and nut was inserted. This was to create enough surface area to prevent the bolt from pulling through the wood. However, testing a full-scale prototype proved to be too much force against the strut, and the bolt acted as a lever and split the wood. The third hub design is completely different. The strut is sandwiched between two spokes. The flat bar stock is welded to the hub at the appropriate angles, and a bolt is placed through the top spoke, through the strut, and fastened with a nut under the bottom spoke. This full-scale prototype shows how 4 spokes of a 6-spoke hub would be assembled. A load test shows it can support my body weight on only 4 spokes, plus none of the other struts are used to strengthen the legs. There was some slight bending of the bolts from my bouncing, but there is no hardware failure. Regardless, the final design will use 3/8-inch bolts instead of 5/16. The central hub is made from 3.5-inch galvanized rigid conduit, which is about 1/4 inch thick. The conduit is cut into 3.5-inch lengths. The galvanized zinc is ground off wherever the spokes are to be welded. Please note that working with galvanized material, especially using abrasion cutting equipment or welding, should be done in a well-ventilated area. Also, you should always wear gloves and safety glasses. I made up a jig that will safely hold the bar stock to the drill press. It allows me to consistently drill a pilot hole in the same location near the end of the stock. Since I have 480 holes to drill, creating jigs and templates is crucial for building an accurate hub. Once the pilot holes are drilled, I switch over to a step bit that will finish the hole at the proper size. I then flip the piece over and gently remove any tear out from the bottom of the hole. Once the holes are in the end of the stock, I then cut it to the correct lengths. I built a stop for my abrasion saw so I could cut each piece to the same length. After cutting off the ends, I can go back to the drill press and drill a new set of holes for the next set of spokes. Now it's time to start assembling. This template has markings on it so I know where the locations are for the 5-spoke or 6-spoke hubs. I just place the hub over the template and draw a small mark onto the hub. This jig is used to accurately weld the spokes to the hub. The hub is placed over the post and each spoke is held in place with a pin. By using this jig, I can weld a complete hub in less than 15 minutes. All the pieces are welded together with a standard MIG welder. Another safety note, please weld in a well-ventilated area and free from items that can catch on fire. Also wear the appropriate gear to avoid burns from the hot metal and use a welding helmet to prevent blindness. Keep fire suppression equipment nearby at all times. No one else should be in the area while using a welder. When each hub is complete, any dirt and rust is removed by sandblasting and is then painted with cold galvanizing paint to prevent future rusting. I hope you enjoyed this video on making a hub for the geodesic dome. The next video will show how the struts are made. Thanks for watching!